Are you excited? I see a lot of yes, alphabet yes in the chat. Okay then, let's start. So, hello everyone. We hope you all are doing good.
Hello?
We, GDSC LBC, is here with an
Content call
awesome tech
Kochi
session.
Ventures as
Oh,
such.
that's so cool. But does this event going to be helpful or just for time pass?
Yes, they will be very useful, and these events are going to be all about machine learning.
Wow, machine learning. So that's great. So when are we going to start this event right now or let's wait?
Yeah, we are almost ready to start. Before getting started, I have a small question for you all.
Really? Throw any question at us. We are ready to answer. What do you say, guys? Type yes in the chat box or else turn your cameras on to say that you're ready. Are you excited? Yes, yes. By the way, don't feel shy to turn your camera on.
Okay,
I
the
see.
question is okay, the question is what do you know about machine learning?
Type your answer in the chat box, guys, or else turn your mics on. Even though if it's right or wrong, don't bother about it. Just speak out.
I need some answers. Anyone? What is machine learning?
Then say yes or no. Okay. Like, do you know about machine learning? Yes, say yes or no. Okay. It's the way of training a computer to solve a problem. It's a type of AI. Okay. Okay then. That was great.
Okay, let's start the event. So our friends Sindhuja and Aksa are going to speak about introduction to exploring ML with crowdsource.
Over to you, Sindhuja. Let me share my screen.
Hi
Is
all.
this screen
Now I'm
okay?
here to tell you the now I'm here to tell you the intro to ML with crowdsource. In the next slide, you will be seeing a video about machine learning.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know. Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk, follow us on Twitter and find us on Facebook.
Okay, now, after watching this video, how would you define machine learning? At the start of the meet, you gave some definitions of machine learning in the chat box, right? After watching the video, how can you conclude machine learning? Don't bother if it's right or wrong, just guess.
Give it a chance, guys. Just type it.
Just type it in the chat section. Okay, if there are no answers, I'm going to explain you now. Machine learning is a specific field of artificial intelligence where a system learns to find patterns in examples in order to make predictions of its own. In other words, computers learning how to do a task without programmed to do so. Okay? Any questions till here?
No, I guess.
Yeah, okay. So let's play a game. As you all can see on the screen, there's a link given. If you tap on the link, okay. If you tap on the link, you are directed to a Play Store where you can see the app called Crowdsource. You can download it, or you can just if you have the app, you can just okay. My friend Aksa had pasted the link in the chat box. You can just go on it and download. It's a fun game, so I hope everyone can participate in it.
Be active and participate, guys. It will be fun.
After stop presenting, I'll be sharing my screen. Everyone, can you see my screen?
Yeah, yeah.
Yeah, okay then. See, as I already downloaded this app, this is the page where uh, you can see all the tasks which you can have fun. Like, this is a crowdsource app. After installing, you can do the login process, and you'll see the interface in this way: image, image label verification, sentimental evaluation, etc. The third task is a smart camera. If you open this, see, there's a bottle here. I'm pointing my camera to this bottle, and when you tap on the screen like this, it will be asking, is this water bottle? Yes, it is water bottle, so yes, submit photo. And the next thing here I have is, we can see if it predicts this is a spoon or not. Tap on the screen. Is this spoon? Yes. Submit. And next thing I have here is mouse. Let's see if the prediction will be right or not. Is this mouse? Submit. So this is how this CrowdSource app works. Uh, did you follow or did you just switch on the screen?
Yeah, we did.
Yeah, if you see, the camera is able to identify the objects you're pointing to, right?
Yeah,
If anyone have downloaded this app, please comment in the comment section that if it's able to predict the objects you're pointing to. Or if you need some time, we'll wait. Yes, that's what it's called, smart camera. Please comment in the chat section if the prediction is right or not, or if someone is still downloading in the Play Store. Okay, but comment something. I have to move on or not. Yeah. Okay. 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 It's working, right? The smart camera is working now. Okay. Let's go on to the next slide. Okay. This is all done. So next slide. Okay. How does this image identification work and how is it recognizing the objects? Any answers for these questions? As you saw in the video, you can just simply give a two word answers. It's okay. But just we want your interaction. Okay. By shape and size. Hmm. Okay, but how? As we are humans, we can see them and say by its size and shape. But how can the computers see? Okay, there's an answer. It was trained with images of multiple objects. No. Okay, right. Mehir is right. By lens. Uh, Actually, it's not by lens. Like, okay, it's also by lens. Like in Google Photos, how it will predict this image and this image are same or not. Like that, in that way, this also works with auto machine learning vision, in which it detects the objects and the uh, helps people to train with custom models that are capable of detecting individual objects in an image, along with that bounding box, which when I show to a bottle, it gave a bounding box, right? So like that, it will be detecting with an auto ML vision. And this image recognition is driven by artificial intelligence, which can automatically recognize objects in an image. Okay, any doubts till here? Okay, okay. Let's go on to next slide. So here's an other game. This is more fun than the smart camera game. So let's do it. Okay. There's no need of downloading in Play Store. Just click on the link which is given. Akshay, so okay. If you're not able to follow that link, just go to a browser and type quick draw. You will be getting the first web. You have to click the first website itself. It is that game. Otherwise, there's a link in the chat box too. It's very much fun. Don't miss this, okay? Just comment in the chat box if you are following this video. Okay. If you're not able to open that link, just see on the screen. The game is already going on. Wow, nice. The time is up. Next tractor. Draw a tractor in 20 seconds. Wow, Amruta, great. Are your all your drawings detected by it? Yeah, great. What about others? Okay, Mehir too. Then okay, Chandana also. Okay, Hemlata. 432. Okay, time's up. Draw washing machine under 20 seconds. See, it's already trying to find out what it is. Yeah, it answered you that it's a washing machine. Yeah, it was so funny. Next. Oh, okay, strawberry. The last drawing. Strawberry. Yeah, it guessed. Okay, done. So in this quick draw, it will ask to draw you six drawings which it tells, and it will try to detect it. So fun. It is funful, right? Interesting. Yes. Yeah. Okay. So how does this game work? How it is recognizing your drawings? Any guess? Yes, Reshma. Okay, funny. Any guess on how it's recognizing your drawings before you're drawing? Before you're trying to draw, it's giving you an options like it may be this or this. How do you think it is predicting? Yeah, no. I'm asking how it is predicting. You're saying it's prediction. No, there's something working under this. Any guess? It's okay. It's able to recognize patterns in checking for sharp corners. Curves. Yeah. Closer. You're closer. Okay. Last prediction. Okay. Bargo has given something, but there's a prediction at the end. Okay. Okay. I'm going to tell you. I'll reveal the secret of this quick draw. It's nothing but yeah. It's neural networks which is working under this quick draw. Neural networks is nothing but it is a series of algorithms that tries to recognize underlying relationships in a set of data through a process that mimics the way human brain operates. So if you're trying to draw a picture and I'm watching that, I can give some guesses like it may be a carrot or a duck or something. So in this way, for the system to recognize what you are able to draw, it is called neural network. In this sense, neural network refers to systems of neurons. Like human beings have neurons, right? In that way, this neural network works. So this is the reason. Sorry, this is the secret behind the quick draw game. Understood? Any doubts still here? Okay. Okay. Oh, no doubts. Okay, next slide. Okay. How does this machine learning in quick draw works? So neural networks is based upon this machine learning. So how does this machine learning work in this quick draw? Here is a clue to how the game works. There is a large amount of data used to teach this game how to recognize the images. If you go to the this okay, if you go see, you will see a number of various uh, images here on the screen, right? In the slide, there are so many examples of various drawings drawn by millions of people, like ice cream, goggles, etc. See, there's an ice cream. If you are going to okay, these are numerous ice creams drawn by different people. See, like earlier, Aksa draw tractor in one way, and if you are going to play the game like Aksa, you are going to draw it in a different way, right? So here there are millions of people who have drawn this ice cream in different ways. This data will be collected by this quick draw game data. It will be stored in this, and you will be able to see many of the ice cream drawings drawn by different people. So if when you are trying to draw a cone shaped thing, then the neural networks which is being in this quick draw, it will be it will be predicting that you may be drawing an ice cream or a carrot. So after this cone shape, when you're drawing the cream on the top of the cone, then it will be detecting that it's an ice cream, not a carrot. Okay. In this way, this quick draw data works. Okay. Any doubts in this slide? Only Bhargav have no doubts. What about others then? Okay. Okay, no doubt. Okay, next slide. So, this quick draw game can be approachable in two ways. First one is rule based. You may already be familiar with this rule based, where you can start with a goal, write the logical rules, and refine through testing until it works the way you want it to. Uh, Imagine if you try to describe a carrot the way you just described this rule based, just as those on the right side of your slide. This approach would get very complicated, especially if you wanted to account for all the possible ways one could draw an object. This quick base is also called as traditional programming because it's the old way of uh, using uh, writing these algorithms, logical rules, etc. Okay, any doubts here? Okay, others? Okay, next slide. The other one is machine learning. First one is rule based and the second one is machine learning. So machine learning is an alternative approach to build software. Instead of programmers creating rules, a model is trained with examples like as we saw in the before slide about the carrots and ice creams with different examples. So a model is trained with different examples rather than trying to define for a computer, like what a carrot looks like and what are its possibilities to draw in a different way by others. The computer is given a lot of varying examples like you saw in the quick draw data. Okay. Oh, the before slide. Okay. Any doubts here? Any doubts? Are they all are sleeping or what? No doubt. Okay. If there is no doubt, I am going to ask a question now. Okay. I want answers. The question is, what might be the limitation of machine learning? I repeat, what might be a limitation for machine learning? I'll explain you the question clearly. Okay, it requires a lot of data to run. Yes, it requires a lot of data. Okay, right. Maybe in. I didn't understand your answers, Sita. She's sorry, Sita. Yes, Mihir, you're right. Because machine learning, I'm giving a clue for others who didn't answer. Okay, machine learning cannot always predict the right answer. So, what are its limitations? I think it need a number of data to proceed. Hmm, I think it need a n number of data to proceed. Actually, this machine learning is based upon the examples and try to choose one from it, right? So, uh, this machine learning cannot be always right and always it will not give you the accurate answer sometimes. So, the I think sorry, I'm not getting your name. Rita. Okay. I think you're trying to say that the data will not be sufficient for machine learning to move forward, right? Is that is that your answer? Yeah, I think so. Yeah, if that's the answer, that's okay. That's a good try. Slow implementation. Slow implementation. Yeah, it needs a lot of data to proceed. So slow implementation is also right. It requires so much combination to train for one machine. Yes, yes. What Mihi said is right. So, let me explain what the answer for what I asked. Machine. What might be the limitation of machine learning? So, this machine learning model is only as good as examples. For example, if all of the examples are triangle for a carrot, okay, it might fail to recognize if we draw a rectangular shaped drawing as a carrot. Understood? We actually keep a triangle shaped for carrot, right? So if we keep a rectangular shape, it'll it'll fail to recognize it as a carrot. That's the limitation. That's the drawback of this machine learning. So we cannot get the accurate answer. So that's the limitation of machine learning. Understood? Okay. 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 Shrita, understood? Yeah. Okay. Next slide. Okay. So I explained you about the two things: rules based approach and the machine learning. So these two have uh, different ways. Like rules based are defined, and the machine learning uh, learns patterns from the given data. And the rules based approach will be like improvements come from algorithms and networks, like we saw in the earlier slide. Whereas machine learning improvements may be from the additional data. It can need additional data in machine learning. Both has its own benefits. So rules based are used to execute discrete logic that need 100% precision. Whereas machine learning is focused on taking number of inputs and trying to predict output. It's important to understand both strengths of each technologies, that is rules based and machine learning, so you can choose right solution for the problem. Okay, understood? Okay, any doubts till the first slide to this slide? Any doubts? I'm going to explain if you have any. Okay, okay, no doubts. Okay, my friend. Okay, now it's okay. Aksa, stop presenting. Now it's quiz time on what you have learned till now of what I explained. Okay, quiz time. Bye bye.
Okay, hi guys. Hello everyone. So now we are going to give you a quiz that is Kahoot. So everybody please open your Google Chrome or um any hello.
Browser you use.
Yeah. Am I
Yeah,
audible?
yeah, you are.
Yes.
Okay, okay. Okay, everyone please open Kahoot. Yes. My friend Boona will send the code. Boona, can you please share the game pin? Yeah. So please everyone enter the game pin after you open the Kahoot that link.
The game pin is not working.
No, it will work. Please try again.
Okay, it's working.
Yeah. Come on, quick.
Come on, guys, only 10 members joined.
Okay. Can you please say who all are done? Yes.
Join in, guys. This will be a fun.
Okay, I guess everybody joined.
No, there are 31 people and only 16 joined. Come on, everyone, please do join. At least if we reach the number of 25, then we will start. Please do join, everyone. At least let's make it 20, then we can start the game. Please do join, everyone.
Yeah. Please do join, guys.
Also, we can see pretty fun names, right?
Let's make Tsunami Team Ocean. Be ready.
Come on, guys. Hurry up.
Join, join, join.
Okay, I think it's better that we start. I think nobody else is interested to join. The game has started, everyone.
Mona, please share your screen.
Okay.
Ranking web search results. What does it come under? Rules based or machine based?
on, Team Fire.
Last question.
Oh, congratulations, Team Ocean, second place. Team Fire, congratulations.
So sorry, guys. There's a network issue, so that's the reason they are always offing the screen share.
Congrats, Team Fire. Let's go ahead. So, idea to implement. While machine learning offers powerful new opportunities, implementing a machine learning system can be more complex than traditional software. This is primarily because a machine learning system is only as good as the data it is trained on. In this section, I'll provide an overview of the process as well as important considerations. Okay, let's watch this video first.
Suppose you have a great business idea, and you've already gone through the effort to frame it as a machine learning problem. What next? How does your idea become a working machine learning solution? The process has 3 phases: data, modeling, and production. In the data phase, you identify the input data that your machine learning system needs to make successful predictions. Data may come from databases, log files, web pages, and even other machine learning systems. Once you identify data inputs and sources, you use statistical tools to draw insights about the data. The better you know your data, the more useful hypotheses you can make. Data rarely comes in an ideal state. Data needs to be collated, possibly by joining different data sources, and cleaned for the machine learning model to work optimally. Cleaner data results in better predictions. For a machine learning problem, you start with the input data and convert it into features. Features are key properties of the data. For a supervised machine learning problem, you transform the outcome into labels. Labels represent the intended output of the machine learning system. Joining data sources, cleaning the data, and engineering the features and labels takes time. Plan on spending a large portion of your time in the data phase. Modeling phase. Along with the features and labels, you set up the kind of machine learning system needed, called the model. Researchers have created all sorts of machine learning models, from simple to complex. Some models classify data. Other models predict numeric values. Tools like Google's TensorFlow support many types of machine learning models for various uses. Before a model can make predictions, it needs training, which is like sending the model to school. First, there are lessons to learn from the data. Along the way, there are quizzes to check knowledge and correct any misunderstandings. In the end, there's a final exam. When training the model, you split the data into 3 sets: training, validation, and test. The training set corresponds to lessons. Here,
the model processes data for the first time. It starts to infer patterns in the data to help make predictions. After you've trained the model once, you quiz it using the validation set. Based on how well the model does on the quiz, you may decide to adjust the model settings, or hyperparameters, which are like dials and switches for changing the model's behavior, and retrain the model again to give it the quiz again. The goal is to iteratively find settings that provide the best model quality on the validation set. When the model meets your success criteria, it's time for the final exam. Feed your model the test set. If the model predicts well, it passes the course and is ready for real use. Once your ML system is ready for the world, it's time to move the system into production. For starters, your system may need integration into a product. You need to figure out what this integration looks like and whether your model interacts with users. Models may need retraining on a regular basis with new data to pick up on new patterns or trends. This training could come from new data sets or from interactions with users. The system needs monitoring. This means tracking system outages, errors, data processing volume and speed, and how successfully it predicts results. Machine learning systems also require maintenance. As with any production system, this means fixing bugs, adding features that didn't make it into version 1, and the like. Machine learning specific maintenance could include testing other models and settings to see if performance improves.
So let me explain that video in simple terms. Machine learning begins with the needs of your users and businesses. With this in mind, you define an objective so know how to proceed. Examples could include predict which friends a user is likely to share a photo with, or suggest the user should eat in a new city based on the restaurants they have visited in the past. Machine learning models learn from examples, so it is essential to find a large existing source of data that is relevant to your problem. Experts say collecting, cleaning, exploring, and other data processes tend to be the longest but most critical part of the process. The arrow pointing back from prediction to data shows the iterative nature of machine learning. You will need to refine your model and perhaps your data collection and processing based on the feedback until it is achieving the results you are looking for. So, like humans are prone to trust results from a computer, we assume our technology will work as designed until it breaks. However, even a well-designed machine learning pipeline can experience issues when it picks up on biases found in the data. So let's look at this video.
Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to adding a feedback tool on the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation. Because technology should work for everyone.
So here we observe that the technology helps us against the human bias. So let's go through another video.
Machine learning systems require lots of data to make successful predictions. What happens when that data is sensitive, such as people's names, credit card numbers, or medical histories? Sometimes, sensitive data is needed to train a model so it can make accurate predictions. But at the same time, this data must be carefully protected. This is the challenge of machine learning privacy. Let's look at an example. Suppose you create a machine learning model to diagnose illnesses based on a person's symptoms. Someone who reports a stuffy nose and a cough might receive the diagnosis, the common cold, whereas someone else with the same symptoms plus a high fever might be diagnosed with the flu. Plenty of other factors might influence the diagnosis too. Does the patient have a medical history of similar symptoms? Did she recently travel to another country or spend time on a farm with livestock? Are other family members or roommates sick at the same time? To train this model, you could feed it information about thousands of people and their symptoms, medical records, and demographic information. This data includes plenty of personal information that needs to be kept private. In addition, the data sets involved might contain other private information not directly relevant to medical diagnosis, such as patient contact information or the credit card numbers used to pay healthcare providers. What steps should you take to protect user privacy? Step 1 is to gather and select only the data that your ML system needs to achieve its goal. The less private data you have in the first place, the less you need to protect. This might seem like common sense, but it takes effort. It's easier to copy a whole database than to spend hours removing the parts that you don't need. Step 2 is to identify any data in your datasets that may be sensitive. For example, people's names, addresses, telephone numbers, email addresses, government ID numbers, and other personally identifiable information, or PII, should be kept private. Another type of private information is user-generated content, such as email messages, YouTube videos, blog posts, and any other content created by known individuals. Be sure to work with your product counsel to determine which types of information are considered private and how to handle them. You also need to make sure you have permission to use the data and whether the data has other privacy restrictions. Be sure to work with your product counsel here as well. Step 3 is to protect the private data. You can do this by controlling access to the data and your ML model, or by altering the data so it's not recognizable anymore, or both. Privacy is a critical concern in machine learning. When you maintain privacy, you build trust with users and protect your company's interests.
Did you understand till now, or are there any questions or doubts? Okay, thank you, Shrita. Let's move ahead then. So it's easy to look at examples of machine learning and see it as magical, right? It does open a lot of new possibilities with technology. We already considered for certain situations whether ML was necessary. In this section, we will discuss what type of problems machine learning is best suited for. Okay. What do you think? Machine learning, artificial intelligence, and deep learning are the same or different?
చిరాకు వచ్చింది
Or is there any similarity?
అది ఎవరు ఇంటరాక్ట్ అవ్వట్లేదు కోటి నాకు చిరాకు వచ్చింది యునో ఐ వాజ్ అప్పుడు ఐ వాజ్ జస్ట్ అబౌట్ టు లీవ్ కోటింగ్ ఫ్యామిలీ గ్రూప్ తెలుసు చిరాకు వచ్చి ఐ డింట్ ఐ డి
Okay. Any other responses?
వాట్ సర్కాస్టింగ్ విచ్ వన్ ఎవరు ఎప్పుడు ఆన్ చేయరు కెమెరా అందుకే అన్నాను కాదు స్టార్టింగ్ లో అయితే పర్లేదురా ఇన్ని రోజులు అయ్యాక కూడా దే డోంట్ టర్న్ ఆన్ ద కెమెరాస్ నేను అయినా ముందే చెప్పాను డెమో అప్పుడే చెప్పాను మీరు కెమెరాస్ టర్న్ ఆన్ చేసి చెప్పాలి అని ఓకే ఓకే అన్నారు అప్పుడు అందరూ ఇప్పుడేమో ఎవరు చేయట్లేదు
Artificial intelligence, machine learning, and deep learning used interchangeably, but there are distinctions between them. Like artificial intelligence is defined as a technology which appears to do something smart. This can be anything from program software to deep learning models which mimic human intelligence. Whereas machine learning is a specific kind of artificial intelligence, but rather than a rule-based approach, the system learns how to do something from rather than being explicitly told what to do. And coming to deep learning is a specific type of machine learning using a technique known as neural network, which connects multiple models together to solve even more complex types of problems. Deep learning, similar to other machine learning models, learns by examples. It's unique because it connects models to other models in layers in order to handle more complex types of data, like as images. Did you understand so far?
అదే కదా
Okay, that's great then. Let's move ahead. So that brings us to this very simplified overview of the history of machine learning. So the key algorithms in powering machine learning were formulated even as much as centuries ago. They come from disciplines like statistics, linear algebra, biology, and physics. For the last few decades, sufficiently large amounts of data were collected to train models, but they were low quality and expensive to train. Lack of progress and prospects led to an AI winter, where machine learning was considered to a waste of time. In the last few decades, the availability of relatively cheap and fast computing power have enabled the complex calculations across large datasets necessary to train highly accurate models. So let's go to types of machine learning. So classification is a common application of machine learning. The system determines which class or category an example belongs to. The output can be a label and a percentage of confidence. For example, here we can see that there's a picture of an animal, like a lion. So if the classifier was trained to identify whether or not an image was a lion or not, it has two outputs, right? Either yes or no. So since it's a lion, it should give yes. And if it's giving no, then there's some error, so we have to retrain it again.
అసలు ఏం మాట్లాడలేదు కూడా క్విజ్ అయినప్పుడు అందరూ
Likewise, we also played a game, Smart Camera, wherein we found that it detects correctly. Sometimes it doesn't detect correctly, so then we train it. It learns from its mistakes.
అదే నేను
right?
అన్నాను అప్పుడు అసలు 4 పీపీటీస్ వాళ్ళు
Next, we
చేస్తారన్నారు
have
ఫస్ట్. నేను
regression.
అన్నాను 4 పీపీటీస్ అవ్వదు,
Regression system
ఒక్కటి
outputs a number,
చేద్దామంటే
for example, how
మీరేమో
long it
లేదు
will take
అట్లీస్ట్ 2
to
అయినా
drive from
చేద్దాం
point A to point B,
అయిపోతుంది 2
or
hours
the
అయినా
likelihood that
అయిపోతుంది అని
someone will
అన్నారు.
click on an ad.
చూద్దాం. నేను
Regression systems can be as
అవును
simple as
మ్యాక్సిమం
drawing a
6:30
line,
కల్లా
as you
కంప్లీట్గా
can
ర్యాప్
see above,
చేసేయమంటాను.
or more complex models depending on multiple variables.
క్రౌడ్ సోర్స్ ఇస్
Another
యాప్ దట్ యు
useful
నీడ్ టు
example
డౌన్లోడ్
of numeric regression
డూయింగ్ దట్.
that might be
పెట్టాను
worth
చూడు
sharing
లింక్
here is
చాట్
things
బాక్స్
that
ఆ లింక్
predict
వాడేసి
money,
ఆ లింకే
like
వాడు,
a sales
ఎందుకంటే అది మన రిఫరల్
prediction
కోడ్
model.
మన జీడిఎస్.
Like see here, it calculates the
మెషిన్
distance
లెర్నింగ్
between
కోసం
A and B,
బాగుంటుంది, చాలా బాగుంటుంది. గేమ్స్
right?
ఉంటాయి చిన్న చిన్నవి,
Or
నువ్వు
it's
కోడ్ ఏం
finding different
చేయక్కర్లేదు,
routes
మామూలుగా
and
జస్ట్
giving us the optimal
యూఆర్
one.
ప్లేయింగ్ విత్ దోస్ మెషిన్స్ అనమాట. బాగుంటుంది.
Next up, we have clustering. Another application of machine learning is determining how closely
చాలా
related
క్లీన్గా అయింది.
items are to one another. In this slide, the data of hand-drawn
అసలు
image is moved
దిల్లేష్
into
కూడా
clusters
ఉన్నాడు, ఏం
of the same
చేస్తున్నాడు,
numbers,
గోలీ అసలు వాడు ఏం
like
చేస్తున్నాడు
ones
నాకు అర్థం
with
కాదు.
ones, twos with twos, threes with threes, and so on. Even within clusters of the same numbers, the images are further clustered
అవును,
by
ఫీల్
those which are
అయిపోతాడు
similar
పాపం
in
వాడు,
shape.
చాలా ఈజీగా ఫీల్
For
అయిపోతాడు.
example, some 2s and 7s look similar. Like here we can see some
చెప్తున్నా
2s
ఇప్పుడు
and 7s.
లీడ్
They look
లేదంటే
almost the
కోలీడని
same.
చూసుకోవాలి కదా. అసలు సాత్వికకి ఇవ్వాల్సింది
So semantic similarity could be a great example for understanding clustering.
ఇప్పుడు ఏం చేయలేము, ఎండ్లో వచ్చేసింది, ఇప్పుడు ఏం చేయలేము.
Next, we have sequence prediction. So in order to assess users,
అది
it can
ఇంకా
help
కంటెంట్ టీమ్ కోసం
predict
ఇంకా
what they
చేస్తారు.
might do next. This could be a prediction of the next keyboard key a user will select, as you see in the screenshot here. Or this could be used to propose a spelling correction or suggest replies to a text message. Like you can see that if you get a mail, then it asks you to reply, it suggests some replies to you. So it's sequence prediction. Other examples of sequence prediction could include the next video a user might want to watch or a next stop on a vacation. You can see sequence prediction in action by using glide type, handwriting recognition, or translation task on the CrowdShare app. The link is shared by my friend Diksha, so please do refer to it. Next, style transfer. Style transfer or style generation. It is actually a new machine learning task available. It involves training a model on one set of data and then applying that model to something completely different. It could be as seen in this example, like making photographs to look like another piece of art, or translating a video from male to female, voice from male to female, or even another language. Like here we can see there's an image which is added with another image of wave. Here it's a tortoise. So both clubbed together, it creates another image. It generates another image. Now that you have seen a few examples of machine learning, let's go through an example. Like we'll have a quiz here. My friend Shanti and Shanti, are you there? Bhuvneshwari.
Yeah, they are.
Yeah.
Can you start the quiz? I'll
Yes,
stop
yeah.
sharing. Before ending, do you have any doubts? Anything you didn't understand? Feel free to text if you have any doubts. Or you can just unmute yourself and ask. Okay, then since you all understood and have no doubts, I'll give the hand over to Shanti. Shanti.
Yes. Okay. We are here with another quiz.
Just a minute. Is my screen visible?
Yeah.
And okay, everyone. Can you see the game pin there?
Please join in, guys. You can join in by entering the pin there. It's going to be fun. Please join.
Come on, guys.
Why isn't everyone joining?
Guys, I'm waiting. Yes, only 6. Come on, everyone.
We'll wait for 5 more minutes. Please join in. It's going to be.
Yes, cutie, ammu, me. Come on. Who is the Durapilla? Like, yeah, yes.
There are 13 members who joined us. The meet has 34 people, so please join in.
అరే కమాన్ 34 మెంబర్స్ ఉన్నారు జాయిన్ అవ్వండి yes
Do you have any issues joining the game? We can help you with it.
18 కమాన్ జాయిన్ అవ్వండి ఫాస్ట్ గా
There are just 17. Okay, we'll wait for 2 more minutes.
yes come on 21 yes
You guys are there? Joining. Where is the excitement?
ఏంటో అందరూ పడుకుని పోయినట్టున్నారు. అసలు ఎవరు రెస్పాండ్ అవ్వట్లేదు సరిగ్గా.
It's fun game, you know. Remind me.
You'll definitely like it, guys. Please do join.
Still 12 members.
Come on, guys. It will be fun. Join అవ్వండి ఫాస్ట్గా.
Let's make it 25 at least, everyone. Please do join.
Yes. Come on, join అవ్వండి.
Just 3 more people. We'll start it. It's already.
ఓకే, ఇంకా ఎవరైనా జాయిన్ అవ్వాలనుకుంటే జాయిన్ అవ్వండి ఫాస్ట్గా. ఐ విల్ బి స్టార్టింగ్ నౌ.
Okay, we'll start then.
Yeah.
Yeah, we'll start. Anyone wants to join in? Okay, Shanti, let's start it.
Okay.
Okay, there is a first question. Recommend the next word in the Android SMS app based on the words typed so far. We got 13 answers in 6 seconds to go. Everyone answer. And the answer is sequence prediction. And we have 10 people giving correct answers. Okay, get ready for next question.
Robust.
Robust in first position.
Yeah. Get ready for the second question.
Labeling email as spam or not spam. We have 22 seconds. Say 9 answers. 10. The options are clustering, sequence prediction, classification, style transfer. And time is up. Correct answer is classification, and we have 10 people giving correct answer. And robust
Okay.
is in first position,
Again.
pillar is in second, LB is in third,
Okay.
and remaining.
So we are moving to the third question now. Get ready.
Identifying trends among just a group of people who have got a new musical list. Come on, guys, answer it fast. 15 seconds to go. We just got 16 answers.
Yes.
Question.
Okay.
In first position. And
Moving to
progress.
the fourth question.
And time is up. Correct answer is style transfer. Okay, the positions are we have pillar in first position, LV in second, and Vidya in third. Next question is here. Determining workout activity based on phone movement. Five, four,
Wow,
correct
there are
answer is
14
rest.
responses.
Guys, I think you got a wrong definition about sequence prediction. Let me just repeat. Sequence prediction refers to predicting the next symbol, and style transfer refers to blending of two images or voice or adding something like that.
Okay,
The
moving to the
question might be
next
wrong.
question.
It's okay. Let's check the correct questions. Identifying famous landmarks in a photo. Yeah, 10 seconds to go. And time is up. Correct answer is classification.
ମାନେ କିଏ ପଡେ ଘରେ କୁକୁର ଗୁଡା କିଏ ରାଖିଲେ ଘରେ ଯାହା ବି ବହୁତ ଇଏ ବଢିଆ କରିଦେବେ ଆଗୁଆ ସଂକେତ ଦେଇଥିବେ কত ইয়ে খালি খালি রকম ছাড় ওসব ছাড় রাঁধুনি ডুমিটা আছে ওর ভিতরে ওগুলো খাতে দেয়নি মা করছিল 5টা পর্যন্ত আমাকে পিঠে হ্যাঁ এগুলো বমি হয় 5টা পর্যন্ত তো খাতে দিবি না ও ছাড় তুই কি কর আমি বলবো মাকে ফোন করে দেখি মাকে ফোন করে পরে নিয়ে নেব କରେଣ୍ଟ ପଳେଇଛି ମୋର ରେକର୍ଡିଂ କରୁଥିଲି